Okay, today we're going to cover sections 4.4 and 4.5 in this video. So you may need to pause and slow down or take notes. I'm going to go through this fairly quickly just because of the length of the time on a video. So if you want to pause it, rewind it, you guys will have this for the rest of the semester to refer to. So let's get started. So multiples of a number. So a multiple of a number can be found by multiplying the number by a whole number, 1, 2, 3, etc. And then what that results in, what we're going to be looking for is the least common multiple of the two given numbers, and sometimes 3, 4, whatever. It's the smallest whole number that is a multiple of each given number. So that's really the two definitions that we're going to talk about first. So let's look at what a multiple is. So for example, if I have the number 4, if I multiply 4 by 1, it's a multiple. 4 by 2, I now have 8. 4 by 3, I now have 12. I can keep going. 4 by 4, I have 16. So as many whole numbers as I can come up with, these, by multiplying it by a whole number, I get a list of multiples. Now, sometimes we're going to need to find the least common multiple, and we're going to be doing that a lot today because of doing addition and subtraction of fractions. So let's do an example where I have a 6. So I'm going to do 6 times 1, I have 6. 6 times 2, 12. 6 times 3, 18, and so forth. Now, if I look at this, I can see that I have a 12 in this column and a 12 in this column. And so those two are the same number, so this would be considered our least common multiple for these two sets of numbers, would be 12 in this instance. So we're looking for the first number that they have in common that's found through multiplication. So we'll use this to find common denominators and other things like that, which is going to be really, really important today. So let's do some more practicing with finding the least common multiple. So I've got 21 and 14. So I can multiply 21 by a couple numbers. Again, I always start with 1 just in case, when I start multiplying by 14, I end up with 21. So I always want to start with that number times 1. 21 times 2, that's going to give me 42. 21 times 3 is going to give me 63. And I could keep going, but the numbers are going to get pretty high. So let's go ahead and work with 14. So I've got 14 times 1, which is 14. And I've got 14 times 2, my pen, which is 28. I have 14 times 3, which is 42. Now you can see I have 42 and 42, and those both match. So my least common multiple would be 42 and this with these two numbers. Okay, so you're just multiplying to find what matches. Okay, so we can do both of these if you want to pause it and try it on your own. But we've got 15 and 25. So if I multiply 15 times 1, I have 15. 15 times 2, I have 30. 15 times 3, I have 45. That's 15 times 4. I get 60. And let's do one. 15 times 5 is 75. So now let's do 25s. 25 times 1, 25. I like 25s, they're like quarters. So I've got 50. 25 times 3, I have 75. Now I don't need to keep going because I got a 75, which matches this 75. So my least common multiple for these two would be 75. Okay? For the next set, I actually have three numbers, 4, 6, and 10. And so a lot of times when I have three numbers, I'm going to look at the largest number and see what kind of things I'll need to be aware of. When I multiply by 10, everything's going to end in a 0. So I need to probably just focus on 4 and 6 and what ends in a 0. So I can do the whole list if I want to, but some of these can get really long. So what I could do is just start thinking about 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30. 10 times 4, 40. 10 times 5. And let's go to 6. So when I'm thinking about, not 10, when I'm thinking about 6 and 4, I'm trying to think of, can I multiply any of these two numbers to get one of these? Well, 20 works for 4, so I could do times 5 to get 20. And I could do 4 times 10 to get 40. And I can, if I'm not sure, then I could do the rest of these, like do this 60 divided by 4 and see if it works. And if I did try 60 divided by 4, that works as well. And that's going to give me 15. So 4 times 15 is equal to 60. So I've got 3 things that match with 10, but now I've got to check and see if I've got anything with the 6. So 6 times 5 is 30, but that doesn't match across, so that's not going to work. And the next one I've got is 10 times 6 is 60. So I've got a 60 here, a 60 here, and a 60 here. So my least common multiple would be 60. So I was just trying to a more of a shortcut to try and get there by knowing that it had to be one of these numbers. Otherwise, it's not going to work anyways with 10. Okay, so the next thing that we're going to work on is we're going to think about changing a complete fraction to an equivalent. An equivalent fraction is just another way of writing an existing fraction, but it's still equal to the same amount. So we find equivalent fractions when I take a larger fraction and I reduce it down to smallest or lowest terms, then that's an equivalent fraction. It just means the same as. So I could write something multiple ways and it still means the same thing. It just may not be in the most reduced form. We use this a lot when we're doing addition and subtraction of fractions. So it's a skill that we'll need to have. So what I do is I can find an equivalent fraction either through multiplication or through division. Now it's the same, I have to have the same number that I'm multiplying or the same number I'm dividing out for this to work in both the numerator and the denominator. So I look at my complete fraction, which is 7/4, and then I have an incomplete fraction. So what they want me to do is take this complete fraction and change it into a new fraction containing this denominator. So because 4 is smaller than 32, I would need to multiply by 8 to get it to that number. So whatever I do on the bottom, I must do on the top. So 8 times 7 is 56. So 56 over 32 is my equivalent fraction. Now I'm not going to reduce that. If I do, I take it right back to 7/4, which defeats the purpose. So we want to keep our new fractions. This is the only time we're not reducing in that new form because that's the goal, is to get it into that new equivalent fraction. Here we've got 11/9. We want to change it into a denominator that contains 72. So if I multiply 9 times 8 and multiply 8 times 11, I've got 88 over 72, which again is my new equivalent fraction. So we can also do this with negative numbers. So here I've got 3/10 into 50. Now this is negative, this is positive. So I'm going to change this one also to match. If I multiply 10 times 5, multiply 3 times 5, I now have 15. I have one negative, so I need to make sure I have a negative somewhere. Remember, negatives can be top, side, bottom. As long as they're there, then that's your negative for the fraction. Again, this is -4/5. It doesn't matter where the negative is. But 5 times 3, so 4 times 3 is going to give me 12. So this negative, again, can be anywhere as long as it creates a new negative fraction. They want them to be exactly the same signs as well as value. Okay, so we want to write the fraction with the indicated denominator. If you want to pause the video and try this on your own and then check back, you can do that. So 3 times 4 and 10 times 4 is going to give me 40 over 12. Now, this was negative, this is already negative, so I'm good. 3/8 to 16, I multiply by 2, so that gives me 6. This is negative, so I need to have a negative somewhere in there, and that would be my final answer. Okay, so it doesn't matter whether I have a variable or not. I'm going to do the same exact process to find a common denominator or to rewrite it with the new denominator. So in order to do that, I have to think about 13 times what is going to give me 26, and that is 2. So since I'm really worried about the denominators, that's really where I'm making the decisions. 13 times 2 is 26. I'm going to multiply my numerator by 2 as well. 3x times 2 is 6x. And so that would be my final answer. So I'm just increasing, and I'm not going to reduce it. If I reduce it, I come right back to 13 or 3x over 13. So when it contains a variable in the denominator, it's a little bit more tricky. So here I have an m and a 2m. So I have to be careful about what I already have versus what I need. So the m's already match. I don't need another m over here. I need it to look exactly the same as this one. So I've got a 2 in front of the m. So if I were to multiply a 2 by my m on the bottom here, I now have matching denominators. So since I multiplied by 2 on the bottom, I'll do the same on the top. And I now have 10 over 2m as my new fraction. Okay, now this one with the variable x or variable squared is a little different. So I still want to change it into this one, but I need to understand what y squared is. It's not a 2y, it's y times y. So I need to write that out. So let's do y times y here, and then compare that to this y here. So if I'm looking, what I notice is that this one has y and y. So I have a y that matches this y, but I need one more. So if I were to multiply y here, I now have matching variables, exactly the same. So if I multiply by a y here, then I multiply by a y up there, okay? So now I have 2y over yy, or just 2, sorry, the y goes over here. 2 over y, I multiply by that y, this becomes 2y over yy, which, when we're working with Alex, we should reduce, or not reduce, but simplify. So it's 2y over y squared. There you go. Okay, so if you want to pause and try these on your own and check back. So I've got, now this one's tricky because I've got the 9. I need to make it not into just 18, but 18y. So I need to multiply this one by 2 just to get the 18, but I also need a y. So I need both the number and the variable to make it identical. So if I do that, I must also multiply 7 by 2y. So I now have 14y over 18y. And again, don't reduce. So this one's w squared, so we can rewrite that as ww, and this one as 10 over w. So what I have is one of these w's match. I need another one, right? And if I do that, I multiply it on the top. So I now have 10w, which simplifies to 10w over w squared. It's squared. Okay? So some key concepts that I want to note before we actually get going into the addition and subtraction portion. You can multiply or divide any two fractions. They do not need to have the same denominator. So what I'm talking about here is only for addition and subtraction, and I can only add or subtract fractions that have the same denominator. So that's what makes addition and subtraction a little trickier, is that we have to come up with common denominators first. Okay, so two fractions are considered like fractions if they have the same denominators. So if you look at these two fractions, they have 11s in their denominator. So I have an 11 and an 11. So the rule is basically I look at my sign here, and since my denominators match, I keep the denominator. I don't change it to 22, I just leave it as 11. They have to be the same, so I keep it the same. Then I simply add 2 and 5, and I get 7, and then I check at the very end to see if I can reduce it, and I cannot. So there's only reducing in the very, very last step for addition, or for the addition and subtraction. There's no reducing like we did with multiplication or multiplication and division within the fraction first. So we can only reduce at the end. Okay, so some rules to add or subtract like fractions. This is still like. We're going to add or subtract the numerators, and we're going to write the result over the common denominator. Now, I do need to add that we will need to reduce if we can. So in this example, I have 2 ninths plus 4 ninths. So that's going to give me 6 ninths. Now 6 ninths I can reduce by 3 in both the numerator and the denominator. So this is going to give me 2 over 3. That is my most reduced fraction, and that's finished. The last one here, it's all subtraction. So I've got to start with 7 minus 5. And 7 minus 5 is going to give me a negative 2. Just positive 2, sorry. 2/12. I'm thinking up here. Now this is going to subtract with 11/12. So I have 2 minus 11/12. That's what I was trying to get to. So if I do 2 minus 11, that's going to definitely give me a negative, right? So I have a negative 9 over 12. So at this point, I look at my 9/12, and I can still reduce it by a factor of 3. So I end up with a negative 3 over 4 as my final solution. Okay? Now, I'm going to add or subtract using variables. Now, this is one of the reasons why I'm going to push today that we don't use our calculators when we're doing a lot of this, because you're going to need to know the ins and outs of adding and subtracting, because once we get to the variables, you won't be able to put this partially in the calculator like we did with multiplication and division. We're working very differently with variables here. So the first thing I note is, are my denominators the same? And yes, they are. So I get to keep my denominator exactly the same. So it's going to stay 4b. Now, 11a and 7, I can't add those together to get one term. And the reason is because 11 has a variable. 7 does not. So it's 11a plus 7 all over 4b. These are not like terms, so they can't be simplified any further. This is my most reduced, my most simplified answer. There's nothing I can take out of it. So it's going to have to stay that way. So let's look at this next example. 5m, my common denominator, so I'm going to keep it as 5m. Okay, now we know that this is really a 1 in front of that x, so we have a 1x plus 3x. Now this time I have variables in both of my terms, so I can add those two terms together and get 4x. And that is my most simplified solution for this problem. Okay, so you have unlike fractions when they have different denominators, and this is where I kind of want to focus a lot more. These are a little bit harder. So you want to come up with a common denominator using the LCM method where we find multiples. So you have a couple things you need to know about denominators. First, you have a 9 and a 6 here. Our lowest denominator cannot be any smaller than the 9. So it has to be 9 or it has to be greater than 9. We can't ever go down. We can always multiply and come up with new denominators through multiplication, but we cannot divide them out. So I could start doing my multiples. So I've got 9 times 1, I've got 9 times 2, 9 times 3. Okay, and then I can do a couple of 6s, 6 times 1, 6 times 2, 6 times 3, and you see that we have a common multiple of 18. So what I'm going to do is I'm going to change both of these over into new equivalent fractions containing the denominator of 18. So I can even go back over here. I did 9 times 2 to get 18, so I can multiply by 2 here and again on the top. So I have 4 18s. 6 times 3 was 18, so I'm multiplying by 3 in both numerator and denominator, so I have 3. So now that I have the same denominators, I'm simply adding my numerators, so 4 and 3 are 7 18ths, and I check to make sure it's reduced. It is, so I'm good to go. So here are some steps, and again, you may want to pause this and write them down or check the notes that I have for you guys in Blackboard already. So you're going to identify the LCD first, and that's the first thing we did. And then you're going to write each individual fraction as an equivalent fraction with the LCD. You're going to add or subtract the numerators, write the result over the common denominator, and that's important. We don't add the denominators, we find a common one. And then finally, we're going to simplify to lowest terms if possible. Okay, so that's always something that we're going to check to make sure it's reduced. Okay, so let's do another one here. So a lot of times what I'll do is if I have a bigger number like 18 and 9, I'm going to look at 18. My common denominator's got to be 18 or more. My first question is, can I multiply something by this denominator to turn it into this one? Because if I can use an existing denominator, that would make my life easier. And the answer is yes. If I multiply 9 by 2, I get 18. So my new fractions are going to contain the denominator of 18. Now, since this one doesn't change, I get to keep 18, I get to keep the 1 on the top. So this is not going to change this fraction at all. 4 plus 1 is 5/18, and that is my most reduced fraction. Okay, so this one right here, I've got 6 and 8, can't be any smaller than 8. So 8 times 1, I'll do 8 times 2, 8 times 3, and I'll do 8 times 4 just to be safe. Okay, and then I'll do some with 6. 6 times 1, 6 times 2, 6 times 3, nothing so far, 6 times 4, and you can see I've got 24 and 24. So my lowest common denominator is going to be 24 here. So I've got 24 and I've got 24. So 6 times 4 and 5 times 4 gives me 20. And 8 times 3 and 3 times 3 will give me 9. So I'm set. So I just need to add them together, and I have 29 over 24. And that is a perfectly good answer. Just because it's improper doesn't mean that it's not reduced. So reducing means I can divide evenly out of each of those. It doesn't talk about the form that it's in. So it can be mixed or improper, okay, as long as it's reduced. So just one more here. We've got negatives, and I just want you guys to be aware to check your signs. So I've got to find a common denominator for 6 and 15. And so if I think about 15, I've got 15 times 1 is 15. 15 times 2 is 30. Now I know that just by looking at this, that 30, I can do 6 times 5 and get 30. So 30 would be a good lowest common denominator for this problem. So I'm going to rewrite this with new denominators of 30 and keeping my signs. We're going to really watch my signs. So 6 times 5, 7 times 5, 15 times 2, and 1 times 2. Now be careful, since they're both negative, that means we're going to add them and keep the same sign. So this becomes a negative 37 over 30. Okay? Now in a problem like this, there's no variables. You guys, I just wanted to make sure you understood how to actually add and subtract. In a problem like this, you could use your calculator. If you are not using your calculator, you're going to want to come up with a common denominator for all three at the same time. So here I would use 60. And the reason I'd use 60 is because 12 times 5 is 60, 5 times 12 is 60, and 10 times 6 is 60. So that would be a good common denominator for this problem. So I'll walk you through it. Now, right here before I get started, those double negatives we know makes a single positive. So all of those integer rules still apply. So here I multiply the top, I have 5. I multiply the top by 12, I have 36. I multiply the top by 6, I have 18. So then it's just simply moving left to right. So I have 5 minus 36, which is going to give me a negative 31 over 60. Then I can add that 18/60ths to that. So remember, I have a negative 31 and a positive 18. So those are really subtracting. And that's going to give me a negative 13 over 60. Again, because that 31 was larger, that's why it's carrying that sign. Okay, so feel free to use a calculator when it's just whole numbers, but I want you to practice a couple without a calculator because of the variables we're coming up to right now. So we need to come up with a common denominator before we can add 9/5 and 2 over y. So a common denominator, if I don't have a number in both, then or if I'm trying to find one on the fly, I can always multiply my two denominators together, and that's going to give me a common denominator, not necessarily the lowest, but it'll give me a start. When I have just a number and a variable, multiplication is the only option I have. So I'm going to go ahead and write these as 5y and 5y, okay? So if I multiply this already has a 5, this already has a 5. What I need is for this to match exactly, so I need a y. And if I put a y on the bottom, I need a y on the top. So I now have 9y. On this side, I have a y, but I'm missing this 5, right? That's what I multiply by. So I have 10. Now you might need to stop this, rewind it, watch it again. It takes a little while to get these. These are a little bit tricky. So now that I have a common denominator, I'm going to keep that 5y as my denominator. And then look, this has a variable. This does not like terms. So it's 9y plus 10 all over 5y. And it cannot be simplified any further. This is my final answer. Okay. This one has x squared. And again, we want to point out x squared means x times x. So you might want to rewrite the problem before you start with the variables written out. Okay, so again, this x and this x, I want them to be the same, right? I want them to have the same number of x's. So I need to multiply by another x here and do the same on the top. So if I do that, then that's going to create the same denominators. So I now have 10x over x squared minus 7 over x squared. So we want to take it back to that simplified variable. So again, not like terms. This has an x, this does not. So I have 10x minus 7 all over x squared. Okay? So if you want to pause and try these two and see how you do, and then come back and check them, that'd be a great idea. So here I've got my variables. I would multiply 8 and z to come up with 8z. Be careful that you note that that's a z and not a 2. So my denominator would be 8z. So I'm going to rewrite that. This one has an 8, matches this 8, so I need a z. So this gives me 7z. Okay, here I have a z. I have a z. I need that 8, right? So I'm going to multiply by 8, which gives me 40. So my denominator is going to stay 8z, and 7z plus 40 cannot be simplified any further, so I'm going to keep that. And that is my simplified fraction. Okay, again here, you may want to rewrite it first where you have your two t's so you can see what you need. So I see that I have a t here, but I'm missing one here. So if I add one in, then I match. So that brings me from, I've got t squared as my denominator. Now if I multiply this side by t, then this side also needs to be multiplied by t on the top. So don't forget to do that part. That's really easy to forget. So we keep our t squared, and I have 11 minus 4t all over t squared. So just watch your signs too. Some are plus, some are minus, and that makes a difference, especially in ALEKS. Okay, so common denominators are another way that we're going to find, or we're going to use those to find which one's greater or smaller when it comes to fractions. So in order to compare these, I just need to figure out a common denominator, come up with equivalent fractions, and then I can compare. So here I could use 8. So 7/8 is a good denominator, or 8's such a good denominator, so I don't need to change the 7. If I multiply by 2, I now have 6/8. So once my denominators are the same, I simply compare my numerators, which is bigger, 6 or 7. So since 7 is bigger, 7/8 is greater than 3/4. Okay? So here I've got the same idea, so if you want to pause it and try it, 3/8 and 4/9. So my common denominator is 72 in this one. So I multiply by 8 on this side. and over here it's going to be by 9. So now I simply compare, is 27 or 32 bigger? 32 is larger, so 4/9 is greater than 3/8. Okay? And then finally, you have to rank some of your fractions in order from least to greatest. So least to greatest. Okay? So least to greatest, again, you need to come up with a common denominator. So 12 would work for all three. You'll start to see denominators a lot faster the more you work with them. So I can keep 5 12s. If I multiply by 2, I have 2 12s. If I multiply by 4, I have 8 12s. So I'm using this only. This right here is only for ranking purposes. When I go back and write my real answer, I need to use the original set of fractions or Alex won't recognize what I did. So when I look through this, 2 12ths is smaller than any of the other ones, right? So that means 1/6 is my smallest fraction, so use that up. And then between 5 and 8, 5 is next, and that's 5 12ths. And then finally, I have my 8 12ths, which is 2/3. So this is what Alex is expecting you to do. Okay, I put this one in here because, again, we're doing it from least to greatest, but they're all negative. So remember that on the negative side of our line, here's my 0, that really the ones that are closest to 0 are my bigger numbers, right? So really, the number that is the smallest that I come up with on the numerator is really the closest to 0, or so that's my larger number, which is confusing. So I'm going to use 45. So that's times 5 times 5. This is going to be 45 as well. 15 times 3. 8 times 3 is 24. And then I have finally 5 times 9. 9 times 3 is 27. Again, that's negative over 45. So really, I'm looking for the largest number is going to be my least, okay? Which sounds weird. So negative 3/5 is my first number because 27 is the largest number, so that means it's furthest away. So if I were comparing negative 27 with negative 25, 27 would be smaller, 25 would be greater because it's closer to 0. So I've used this one, and then 25 is next, so that's going to be negative 5/9 because, again, I want to use my original fraction. And then finally, negative 8, that's an 8/15 because the 24 is the smallest. So be careful with those negatives.